Experienced cybersecurity professionals routinely walk out of the CISSP exam having failed. They don't fail because they misunderstand encryption algorithms or firewall configurations. Their engineering competence is usually flawless. This split interface shows exactly why the disconnect happens. The industry operates in two distinct domains: tactical mitigation and strategic executive governance. ISC2 does not design this certification to test your ability to neutralize immediate technical threats. This creates what we call the engineer's trap. When presented with a governance problem, a technical specialist instinctively reaches for an immediate localized patch. To pass this exam, you have to entirely abandon the mindset of the technical specialist. You must adopt the framework of a security manager, a leader whose primary job is balancing risk, maintaining governance, and aligning with business objectives. Without this structural, risk-based shift in your decision-making, your technical mastery actually becomes a liability. A network engineer looks at a vulnerability and asks, "How do I stop this specific attack?" A security manager looks at the exact same data and asks, "How do I reduce organizational risk sustainably?" This diagram illustrates how a security manager evaluates every operational decision through four specific, non-negotiable lenses. First is business. Security exists purely as a support function for business operations. Every security decision must be evaluated by its direct impact on broader organizational goals. If an action interrupts the business without justification, it is the wrong action. Second is risk-based prioritization. Just because a vulnerability exists does not mean it warrants immediate action. You have to mathematically filter your response by calculating the likelihood of exploitation, the potential impact, and the organization's overall exposure. Third is policy over technology. Processes and governance must always dictate the choice of tools. A firewall or a rapid technical patch cannot serve as a replacement for poorly designed security policy. Fourth is long-term strategy. A security manager shifts the focus from reactive incident response to proactive enterprise planning. The primary goal here is systemic recurrence prevention over isolated incident mitigation. The CISSP exam requires you to view multiple choice questions through all four of these lenses simultaneously. Any multiple choice answer failing to satisfy these four pillars is merely a localized technical fix, and therefore it is the wrong answer. This scenario shows a classic CISSP test question. A critical system vulnerability is abruptly discovered within an enterprise environment. You have four options: A. Patch immediately, B. Shut down system, C. Perform risk assessment, or D. Notify technical team. For candidates with a strong technical background, option A is the instinctive, reflexive choice. It feels correct because it represents the fastest path to technical remediation. You see a hole, you patch it. But immediate patching ignores massive structural and business impacts. By selecting option A, you are ignoring unquantified downtime implications. Applying that patch might break a critical database in the middle of the workday. You are also committing unauthorized change control violations and completely circumventing formal risk acceptance procedures. The correct managerial heuristic here is option C, perform a risk assessment. In a mature governance framework, risk quantification must strictly precede any technical action. You have to know what you are fixing and what breaking it will cost. Technical remediation operates in a vacuum. A risk assessment loops in executive communication and ensures your actions align with the business. ISC2 consistently penalizes action taken without an understanding of the underlying business risk. The best answer on the exam is rarely the fastest technical fix. It is the most balanced business security decision. This 5-tier hierarchy illustrates ISC2's strict sequential decision-making framework. It acts as a non-negotiable rule system under pressure. At the base is technical implementation. This is the final and least prioritized step in the security decision cycle. Above that is policy and governance. Established procedures must always override and dictate technical execution. On the next tier sits risk reduction. Both your policies and your technical tools are strictly subordinate to quantified risk evaluation. Above risk is business continuity. Enterprise operations supersede localized risk management and technical policy. At the apex is human safety. This is the ultimate priority, overriding every other business, risk, or technical consideration without exception. When you sit down for the exam, you use this sequence to evaluate your options. You compare the available answers and select the one that satisfies the highest possible tier. Referencing this sequence provides a method for eliminating answers that are tactically correct but strategically wrong. This expanded view brings us back to that initial disconnect between technical reality and strategic governance. The core rule of the certification is that it tests leadership and decision-making architecture. The exam assumes technical competence. It evaluates managerial restraint. As you read every single question, you need a definitive operational mantra. Always ask, what is the most strategic, business-aligned answer? You must directly counter the engineer's deeply ingrained reflex to constantly ask, what is the fastest technical fix? Shifting your cognition from a reactive technician to a proactive manager is the single highest leverage strategy you have for passing the exam. Returning to your technical habits during the test will inevitably lead you to choose the trap answers designed by CISSP. Cybersecurity mastery at the executive level demands a rigorous understanding of when, why, and how technology must be applied to serve the organization.